All right. Good morning, everyone. My name is David Skenazy, and this is DNS Service Discovery. If you're here to discuss another topic, this is the wrong room. Our chairs today are going to be Tim Wasinski and myself, since our other co-chair, Tim Chon, couldn't make it all the way to Singapore. I wanted to start it off to give thanks to Rolf Drams, who's been chair of Dnssd ever since we started. And so I think he's been doing a great job, and I would love if the room could give him a quick round of applause for his years of service. So thanks, Rolf. A little bit about myself. I've been working at Apple for 3 years, not necessarily on Dnssd per se, but closely related topics, and happy to be taking on this new position of chair. This is going to be fun. So first and foremost, please note well, in case you haven't read this, please go and read it. If you ever want to contribute or say anything, it does have some rules related to it, but everyone should know this by now, hopefully. So we have minutes in DriverScribe, so thanks to Bjorn and Barbara for taking minutes in the Etherpad. If anyone wants to look at it and feel they want to add something, feel free to do so. And thanks again. And thanks to Michael for being our Jabber relay. So we have some few useful links here just for future reference. If you want, all the slides are up on the data tracker, and all the document information is up there as well. Quick update on status. The authors will go into more detail, but DNS hybrid proxy went through the ISG. Dnssd push is about to, and we're still working on getting the pairing info through DNSOP, but that should be happening. Sorry, DNS session signaling. Our goals for today is to discuss the drafts I just mentioned and kind of review status and see where everything's at. Possibly the minor changes that we've seen recently. Do a quick review of how all our new architecture, what we're trying to do, and how all this fits together into a very useful package. And we're going to have a longer conversations around the end of the session to discuss privacy. Also, Tolis will give a quick talk on GRASP and how that integrates with Dnssd. So here's our agenda for today. Would anyone like to bash the agenda? All right, without further ado, Stuart, please.
Okay, a quick update on documents and work. I will try not to take too long on this so that we have plenty of time for the interesting privacy discussion, but of course feel free to step up if you have any questions. We did our last call on the discovery proxy. Did not get a lot of discussion on the IETF list. This document is pretty mature by now, and I think everybody who has an opinion on it has already commented, and that feedback has been incorporated. The Security Directorate review talked about privacy considerations. The Operations and Management Directorate review talked about information leakage. So this is actually very timely considering the work we're doing on privacy. The only third comment was the general area felt that it was only at the end of the document that it all made sense, and Joel asked for a bit more introduction. So those are all easy things to fix. We also had a little bit of a legal runaround with the IPR disclosure, which was originally accidentally filed on the requirements document, which is hard to see how that makes sense because it's hard to have patents on a requirement. We asked for that to be removed, and the wrong one was removed. And then when it comes to anything legal, nobody wants to do anything for fear of getting in more trouble. So I want to thank David for a lot of legwork and detective work and tracing the history and sending emails and finally getting that sorted out. So the correct IPR disclosure is again back on the website. DNS push notifications is pretty polished and finished. It can't proceed until the DNS stateful operations document is published, what used to be called session signaling. There is one question which we need to discuss, and I think the authors need to sit down with Andrew to discuss that, because we had a section describing how you discover which server to talk to, which documented what our software at Apple has done since macOS 10.4 in 2004, which is basically an iterative algorithm originally used for DNS updates. Some DNS update clients require you to put in the address of the server you want to send the update to, but we don't like configuration, and we don't like making the user type in something that the computer ought to be able to work out for itself. And the DNS has this wonderful delegation hierarchy where you start at the root and you find out who is the server authoritative for a given domain. So that was the logical thing to do. If I want the host name of my laptop to be stuartslaptop.mobile.apple.com, I shouldn't need to tell the computer what server is responsible for that. The computer should work it out using the DNS hierarchy. So that's what we did. Basically, the algorithm is very simple. I look for the SOA record for stuartslaptop.mobile.apple.com. Chances are that SOA record doesn't exist because that's not a zone cut. So I will get a negative answer, either an NX domain or a no error, no answer, negative response. You can then iteratively chop one label at a time until you do get a positive answer, and then you have discovered the closest enclosing zone. As an optimization, for negative answers, servers are supposed to also include the SOA of the authoritative server that says this name doesn't exist. And that lets you shortcut the iterative steps to go straight to the SOA that you're looking for. So that was one page in the document. And As a response to the last call comments, that got significantly changed in a way that I fear doesn't make sense anymore and removes the shortcut to avoid the iteration, so it generates a lot more packets, and it actually has some cases that don't work. So unfortunately, we're going to have to fix that. Hopefully, we'll have time at the end of this meeting to do that. The document push notifications it's blocked on is what used to be called session signaling, is now called stateful operations. That document is pretty stable right now. We had one recent change about whether all requests require responses or not. The consensus is they don't require responses, but some of the places in the document were not updated to reflect that. So this week I actually did a thorough review, rereading that document from start to end, and found a few of those inconsistencies. We will fix those, and DNS op chairs have promised to do a last call in December. At the last IETF, you may recall Ted and I introduced a few new documents. These three have not been updated. We did, however, do a lot of work on the multicast DNS relay. This was an inspiration of Ted's. Ted has a lot of background in DHCP, and DHCP uses BootP relay agents to avoid having a DHCP server on every physical link. And that concept applies quite naturally here as well. So Ted and I have been working on defining a simple, lightweight protocol analogous to a BootP relay, which we're calling a multicast DNS relay. We submitted draft 00 for the last IETF. We submitted draft 01 in time for the cutoff 2 weeks before this meeting. And we did a bunch more work at the hackathon. We planned this year on having a table at the hackathon, which we did, and we announced it. Many of the regular contributors to Dnssd are not here in Singapore for various reasons. So in the end, it ended up being Ted and me having a table to ourselves and 2 days of focused face-to-face time. We did some coding, and as a result of that, we realized things that should be changed in the relay document. And I submitted that Monday morning, which I know is too late for anybody here to have read it, but if anybody is starting to read it now or is going to read it on the flight back, I wanted them to have the latest version available, not the previous one. Nothing substantive in how the protocol works has changed, but the way we describe it and explain it, I think, is a lot clearer now. So that is the end of the document updates.
Thank you, Stuart. Ted, next to talk about HomeNet, please.
Well, that was just about the shortest hour ever.
Yeah, and I covered all the hackathon discussion too.
Yeah,
Yeah, that was it.
I mean, I could give you a blow by blow if you want.
Sure. Yeah, line by line, please.
Right. Yeah. No. I mean, actually, a bunch of code got written. We were hoping to do some interop testing, but we didn't quite get there. Okay. So I'm here to talk to you about HomeNet and Dnssd. Oh, look at that. I don't have to turn around. All right. So why am I talking about HomeNet here? This is the Dnssd working group. The reason is because one of the main things that you need in order to make a HomeNet work nicely is service discovery, and Dnssd is how we're doing service discovery on HomeNets. So HomeNet is kind of the simplest, maybe simple isn't the right word, it's the least managed use case for Dnssd. And so it's a pretty interesting use case to be looking at if you're interested in Dnssd. We call HomeNet because that was kind of the motivating use case for forming the working group. But what we're producing is actually probably applicable to more than just home networks. By the way, Stuart, Stuart asked me to come up and give this talk. I don't actually know what his goals were for this talk, so I basically just came up with some slides about this because I think there are some interesting things to say here. But Stuart, if I miss those goals, please get up at the mic and point it out to me. So anyway, continuing. HomeNet, the documents that Stuart and I have been working on have been motivated largely from my side by the HomeNet use case, and I think they have actually been very interesting and produced some interesting opportunities for work. The working group has completely turned over in the last year in terms of management and focus. If people in this room have been to the working group and stopped going, you might want to come back. There's some interesting work happening in HomeNet, and we'd really like it if we had more help. This is a duplicate of many of the things that I said on the previous slide. Let's see. So the main difference is the main things that make this interesting are we're doing Dnssd without any professional management. So there's no IT staff managing the network. It's just got to work. Another thing that's interesting is we have a name hierarchy, but we don't actually have a global domain name. So that creates an interesting set of problems that are worth working on, I think. Dnssd hybrid currently depends on there being a mapping between the physical hierarchy of the network and the network topology. So in other words, for naming, you want to be able to say this network is the building 1 east network, and this network is the building 1 west network, and this is the 3rd floor network, and stuff like that. And we don't have that. We don't have any way to establish names like that on a HomeNet. So that creates some interesting problems. And then, of course, trust establishment on the HomeNet is a problem. So, and the problem that motivated Dnssd Relay is that we want to be able to support routers that may not be quite as high functioning as, so Dnssd is running essentially on HomeNet routers. We want to be able to support routers that are not particularly high functioning, but also be able to support routers and add features if we get routers that have more capabilities, or if we have a home server or something like that, we'd like to be able to have maybe a stateful DNS server instead of just this stateless hybrid. So I think this is a really interesting problem set. To address this, we split out the discovery proxy as Stuart just said. Stuart and I came up with the service registration protocol, which uses trust on first use name claiming. So you publish a name with a signature on it, and you sign the update using that signature. And then if somebody else tries to claim the name, they can't because they don't have the key that you use to establish the signature. So that's a nice way to do stateful management of service publication. Let's see. We have to automate the management and configuration of discovery proxies and relays, which is actually a lot of text in the hybrid proxy document. If you look at the document is, well, when I did the original version of the document, it was actually about 25 pages and it wasn't done yet. And about 10 of those pages were OAM. The document is now more like 15 pages of meaningful text. I cut down the OAM quite a bit because I thought it was a little bit impenetrable and a little bit too detailed. So the point being that's a big part of setting up the discovery proxy, hybrid proxy thing, is just getting it to work, getting it configured to work. And then the other thing that we're doing in HomeNet, which is not really a Dnssd thing, is trying to automate trust establishment. I mentioned that because there may be people in this room who are interested in automatic or automated, it's not automatic, but automated trust establishment in contexts like this. So I also want to be able to use the work that we're doing here to populate name servers, actual authoritative name servers, and connect them to the DNS hierarchy so that we can do ACME, and so that we can do things like access resources on the HomeNet from off of the HomeNet for people who want it. And I'd like us to be able to do DNSSEC. And so these are interesting things that I'd really like to be doing in the HomeNet working group, but there isn't a lot of interest for doing this in the HomeNet working group. If these are problems that you guys are interested in, please come to the HomeNet working group and participate in that. I think it would be great. So the things that I I've asked you to do a bunch of things. Now I'm going to ask you to do more things. We need help doing the work that Stuart and I are doing. It's no good if Stuart and I are working on it, nobody else is reading the documents. So please, if you can, read the documents and send us comments and consider implementing. If you're interested in looking at implementations, I have an open source implementation of the hybrid proxy that is incomplete at the moment because we didn't quite finish what we were doing during the hackathon, but will probably be complete within the next week. And if anybody's interested in that, I'm not sure quite how to, I didn't put a link here, but send me email. Hopefully people know how to find me on email, and I'll send you a link to the GitHub repository. You can take a look at it. So this is actually a repeat of a lot of stuff that was on the previous slide. One thing I'm not going to read everything that's on this slide because you're already probably bored, but I did a couple of presentations in the in the HomeNet working group that are relevant to this topic and that you may find interesting if you're interested in this project based on what I've said so far. So if you are interested, please go look at those presentations. Even if you just look at the slides, that'd be great. Phyllis?
Thomas Eckert. Yeah, just one quick question. I'm as much a protocol geek as anybody else in the room, but if there's any,
Speak closer to the mic, please.
yeah, if there's any, interesting new insight about, how the use cases would be pumping up with HomeNet, right? That HomeNet would actually having any chance of enabling more services, to be dynamically discovered, announced, or so. That would be cool if there's any specific insight on that.
Do you mean? I mean, so right now Dnssd is basically just whatever service you want.
Right.
So
And
I mean,
it has a certain amount of adoption in the industry, and we know it doesn't
Yeah.
have adoption in other areas.
Right.
And so I
Yep,
was
yep,
wondering if there are any, insights that HomeNet might actually help to create more adoption.
yeah, that's a good question. I don't know, Stuart.
I think that's good feedback. Can you give us suggestions? What are the areas, what are the industries you think we should be approaching to work with on this?
Stuart, you might want to mention you and I have actually had discussions about how to discover IoT devices on the HomeNet, which is something that's I think highly relevant and not particularly known to. I mean, people aren't necessarily using MDNS right now for that, so that would be something to talk about.
Yeah, I think, going to whoever is potentially building HomeNet equipment or even equipment that does something similar like HomeNet, and, who would say, hey, before we saw HomeNet, we didn't even think about having, to bother about service discovery, right? So that would be the set, right? I mean, there are obviously people even, building derived solutions that don't employ all the other HomeNet pieces, but hopefully the service discovery piece.
Yeah, I'm actually cautiously optimistic about the use of DNS service discovery in current products. Partly this is based on just personal anecdotal data. I bought a new house a couple of years ago, and as part of the process of buying a new house, you end up buying a bunch of new stuff. And I was actually shocked about how much stuff I bought had multicast DNS service discovery in it. I bought a surround sound amplifier for the speakers in the ceiling in the living room, and it has a web UI. So instead of configuring it up, down, left, right with the remote control, it's got a web UI. The garden sprinkler controller, the inverters for the solar panels. I've actually been surprised at how much stuff has adopted it in areas I didn't even know about.
I totally get that point, but I was going specifically to Ted's presentation that HomeNet is great for DNS service discovery, and that relationship I haven't yet, but I haven't looked, right, but I haven't seen good proof points that HomeNet, just people reading the draft, implementing things that helps Dnssd. I think all these examples that you're giving, they're probably predating HomeNet anyhow.
So yeah, I mean, I think the point I was making about HomeNet relating to Dnssd and it being an interesting place is that, and I guess I didn't actually explain this in as much detail as I perhaps should have. the fact that we need to be able to support stupid routers and smart routers on the home net is actually what motivated me to have the conversation with Stuart that produced the hybrid proxy stuff. So essentially, the sense in which I think HomeNet is interesting is not so much that it's necessarily what everybody's trying to do, but it's sort of a crucible, right? It's a place where the absolute minimum support for getting things working is present. And so can we get DNSSD working reliably in that environment?
Yeah,
I think that's a really interesting question.
That's what I meant initially. That's the protocol geek aspect, and I totally
Yeah.
get that, right? I
Yeah.
was trying to bring up another aspect.
Oh, okay, I'm sorry.
Michael Abramson. So I think what I was going to say was a lot what you just said when it comes to Crucible. So HomeNet shares a lot of mechanisms, or the need for certain mechanisms, like IoT. You were talking about the trust establishment. That's like shared with these enrollment of new IoT devices. Small, medium enterprise probably want to use very similar technology as HomeNet. So Dnssd could be present in the solution space for all these what we're talking about. So we shouldn't have the whole. I mean it's like a matrix of things you put together to create a working solution. And what HomeNet has is that there is no professional management, but you still need some kind of minimum interaction of saying yes, I trust this device, or yes, I trust that person's devices, or whatever when it comes to the trust establishment. But then you still need to discover the services and the devices and initiate the initial contact. So anyone interested in any of those spaces like IoT and secure, please come to HomeNet and, or share if there is any technology we don't know about. And that would also be of interest for HomeNet.
I think that one of the areas of overlap here is one of the key parts of HomeNet, as I understand it, is home networks that are more than one link. So routed networks rather than bridged. And on bridge networks, link local multicast is fine. But when you move to multiple links, you need some way to glue those together. And that's what this working group is focused on, not just for home networks, but for enterprise, large Wi-Fi installations, mesh networks, other technologies. But the overlap is what's common in both of those cases, both HomeNet and here, is you can't assume a single link and link local multicast anymore. So there's definitely synergy there. While I'm at the microphone, a comment I was going to make about the relay to build on what you said. I don't see it just as for less capable home gateways that can't run a full discovery proxy. The other benefit here is often your home gateways don't get updated very regularly, and you might have 3 or 4 different Wi-Fi access points, maybe from different vendors, and if all they have to do is implement the relay once, and it's a pretty simple thing like a BootP relay, and the spec really doesn't change, there aren't bug fixes, there aren't new enhancements, then that bit of gear can be 5 years old, but you can be running the latest discovery proxy on your controller or your main gateway or whatever the device is, and that can get regular software updates that add new features, new capabilities, new user interface configuration options so that you can filter what services are visible in what places, and all of that innovation can happen in one place without having to do a forklift upgrade of every router on the network every time you add a new feature.
Thanks. So I think that's pretty much all I had to say. I don't think we have any questions to ask. Just if this stuff is at all interesting to you, or if you're not sure it's interesting and you want to talk more about it, talk to me or talk to us, or come to the working group.
Thanks, Ted. Torles, if you. No, for the first time, we don't have a pink box. We have a half pink box. It's a little disconcerting.
Let's think outside the box. So yeah, so this is basically something that we are doing at the end of our ANI work in the animal working group, which is coming towards RFC side and doing all these details that are very specific to Dnssd, because we kind of felt that there was more details than we could do in the basic graph themselves. Next slide. Oh, I got the clicker. Okay. Okay, so quick overview of what the animal working group does with respect to service discovery. So what it actually builds through something called ANI ACP is an automatically built hop-by-hop encrypted VRF, considered the VRF Lite with encryption, to manage and control networks, right? So management and control traffic for network services, agents, all that stuff is meant to go through, whether it's a fully autonomic network where kind of, you don't even need a big management center in the back, or you have a classical SDN solution where the network devices primarily talk with all type of crap in the both backend in the NOC. ACP and ANI, very lightweight from the functionality that they implement, and also what we want to have, protocols using the ANI expect to have, and that's only IPv6 unicast routing and forwarding. So there is no definition of DNS or expectation that DNS must be available, and no IP multicast. So, which begs the question, how do you do service discovery then? Because obviously in something that is meant to be self-configuring and self-organizing, like an autonomic network, you need that. And so this is a part that GRASP does, which is a new protocol defined in the animal working group, which does a bunch of things. But for the discussion here, it provides service discovery. These are, by the way, the old slides that you can still upload. Yeah, kind of half an hour ago or so. That's fine. There was some better words missing. So what we have in GRASP is the ability to do announcement and request messages, not only for service announcement like the Dnssd, but for any type of group communication that requires that type of flooding. And they are hop by hop reliably flooded across that secure automatically built infrastructure. So the header of these messages has an element called the objective name. That's specifically not service name, but more broader term, encompassing services as a possible subset. Hop count sequence number for the loop-free flooding. And so you can consider the objective name really as the address for endpoints that are trying to do group communication via GRASP. The payload itself is undefined, right? It's up to the application, the objective, the code, the ASA, whoever is writing that, except that everything GRASP has to be structured through CBOR, both the header and the message itself. Next slide. Oh, sorry.
Michael, I think we have a comment in the Jabber.
Sorry. So Ran Atkins says that slide 2 is unclear. Are they saying link local multicast is not available, or merely that there is no multicast forwarding option?
So link local multicast for this discussion is not used and not required and not assumed to be there. In this particular, ANI ACP. In GRASP in general, we're also supporting the ability to do the flooding through the use of link local multicast, but in the end, it's always a layer 3 network, so it needs to be flooded across multiple hops. So link local multicast itself wouldn't be sufficient. Okay, so the use cases, to bring it down practically when we're saying service discovery and service announcement, what are we really talking about? So for the ANI ACP itself, we really have only, 2 mandatory interesting servers. Okay, follow up?
So Ran Atkinson again did not answer the question. Is link local multicast available or not?
Let's say no.
Brian Carpenter, one of the authors of the GRASP protocol. Yes and no. I mean, if you happen to be running on a point-to-point link between 2 nodes, which is the way the autonomic control plane works, then strictly speaking, there is no multicasting. But if you send the link local multicast address, the packet will be delivered anyway. So the answer is yes, the GRASP daemon can believe it has link local multicast, although in practice it's emulated over a point-to-point link.
Yeah, so in the GRAS spec, we're basically, writing in a way that linked local multicast can be used. But in the ACP, we're actually putting GRAS over hop-by-hop TCP connections so that all the stuff is also hop-by-hop reliably flooded, as opposed to, hop-by-hop multicast forwarded and with loss increasing on every possible hop.
Hi, Stuart Cheshire. I'll say my name every time, even though you probably know who I am by now.
Thank you.
I think it would be helpful. Right now, you're diving into a lot of details, which is good. We should continue this. But it would help me understand how these fit into the big picture. If you could give some background about what kind of network this is and what kind of devices. Are these bits of equipment connected by serial ports? Is it Wi-Fi? Is it Ethernet? Is it 802? Yeah, 802.15.4 radios. What is this for devices in the home, like light switches and home automation? Is it factory equipment? Because right now I have absolutely no mental model of what we're even talking about.
No, fair point. So Anima was scoped to be for well-managed networks, and that was basically after, in the BOF phase, we kind of butted our heads against HomeNet, and that was the politically correct term to distinguish ourselves from HomeNet, which we also consider to be an autonomic network in that sense. So basically, to all the questions that you were asking, the answer is yes, except for HomeNet, where we wouldn't want to introduce a lot of the complexity the solution overall has, because a lot of that complexity is meant to support the well management of the network. So it's going to be an enterprise network, a service provider network with all the possible underlying connectivity options that you were mentioning, except that we right now haven't done the potentially additionally necessary work to look into the lowest kind of smallest device networks, kind of stripping it down through CoAP and other protocol choices. That's ongoing work in Sixtish and other groups that are picking up parts of Anima.
So when you're talking about well-managed networks, I'm still trying to get a mental picture. Are we talking about like $50,000 big iron routers?
Yes.
Okay. So this is an alternative to using SNMP or something for managing your enterprise equipment. Is that?
So the ANI by itself, in the first place, is meant to provide the secure infrastructure to enable management on top of it. And basically what we would like to have is in the future, of course, new, better, not that much provisioning-centric ways for how management and control service and network are running. But there is specifically one draft that simply says, okay, what you simply get from the ANI adopting it for an existing CDN network is that a CDN controller simply through this connectivity gets the ability, to announce the services, to figure out the topology of the network, have reliable connectivity, even if itself misconfigures the network and breaks the routing table, because the whole infrastructure we're building is in parallel to whatever the controller configures in the network. It's kind of a, second invent virtual management network. And that, of course, as you can easily imagine, is a layer of complexity that is really helpful when you're starting, multiple application developers writing all type of crazy CDN software. And it's not that necessary if you're looking at the ultimate goal of HomeNet, which really tries to be as simple as possible, I hope.
Okay, so I think maybe I'm getting a better idea. So a deployment scenario might be Akamai's data center. This is a bunch of equipment in racks in a
Yeah. So
data
I mean,
center.
when we've been looking at the urgent or the value of this technology in different use cases, and the work on where pre-standard versions of this have been developed and implemented, then the data center was kind of at the tail end of that, but rather something that has wide area network links where it's starting to ship equipment that potentially is unconfigured to places where you don't have any intelligence in the room, and trying to have that stuff work reliable. So those were kind of on the top of the list of use case requirements to drive Anima.
So these initial implementations, what are they running on right now?
You mean platforms?
Yes.
So there is an autonomic networking feature set in Cisco iOS. You can look that up. That is pretty much across all the enterprise product lines. So you can have that in campus equipment, in wide area enterprise equipment. So that's basically the implementation I'm familiar with.
Okay, so this is in Cisco products right now, so you can just like plug a bunch together and power them on, and they self-configure, and you don't need some Cisco IT guy to tell you how to set it up.
Yep.
Is that the idea? That's the autonomous part, is
Mhm.
just plug it together and you have a CDN automatically.
Not a CDN, just a normal enterprise network, except that you can't get user traffic through. The only stuff that you can get through is the management traffic.
Brian Carpenter again. Tell us, typically, you're not talking about as an implementation that conforms to the specs.
No, as I said,
but you're talking
pre-standard
about a pre-standard
implementations of the-
implementation.
Mhm.
I've got a presentation which is sort of autonomic networking overview. In my personal opinion, I'll send a link to the working group list, give you a bit of background. But the short form is plug and play networking for the enterprise.
That's one way to sell it, sure. But for service providers as well, it's just if you look at how vendors implemented different things, there are different priorities. So it's a different, more complex story to explain for the service providers.
Yeah, so there was another question from Anna Thielson about how IPv6 neighbor discovery works if multicast is not available. But I think that it sets up that would work.
Draft IETF Anima autonomic control plane.
Huh?
The answer is in draft IETF
Right.
Anima autonomic control plane. It's longer. It's kind of beyond the kind of. I've only got limited time here. So really high level for this, autonomic infrastructure that provides IPv6 routed connectivity to operate. We have two services that need to be, announced by the server instances and need to be discovered by all the, network equipment, all the routers and switches in the network. And one is for Bootstrap because every device in the network is trying to provide proxy support for new devices coming along. For the devices that don't have credentials, and obviously because without credentials they can't get full IP connectivity. So you need proxies, and that's basically discovered through one service. And then the second one for certificate renewal, you also need to discover a certificate renewal server. We're using EST RFC 7030 and announcing that. And there may be more servers for that. And then for the traditional SDN or traditional network management model, well, you've got all type of servers in the NOCs, data centers, however you want to call them. And typically, today you're creating on every device the magic initial network infrastructure config where you have the bloody IP addresses of 10 of these different servers, and most often you can't even nicely figure out failover if one IP address goes down. So you're then going to another server in the data center and changing that to use exactly the same IP. I mean, if you've only dealt with service discovery in the user space, you don't even want to know how bad it is often in operations of networks in their management, right? So syslog, time, netconf, DHCP, DNS servers, how do you configure them on routers, radio server, diameter TACACS for authentication of access to the routers themselves, yada, yada, right? So all that stuff, the idea is that you want to be able to have these just announce themselves in the NOC, and then all equipment that's running ANI would be automatically discovering them. So, okay, so hopefully we've cleared up a little bit the background, the use cases, but why this draft again, right? So we do not want to reinvent for ANI ACP grasp any aspect of service discovery that we've already know and hopefully love from Dnssd. And that was to page 1, right? Every grasp objective must come with its own name and how to encode any attributes. And so that's basically what we started to do initially. And that wasn't really working well because, every time I said, well, in actual deployment, I think we need this other parameter. Let's call it the priority of the server. Then there was the long discussion. Why do we really need this? And so I'm saying, yeah, there's this thing that we have in the IETF since a decade or so, and it's proven pretty useful. So then, of course, there are a lot of things in DNS, primarily that Dnssd inherited or sometimes created by itself, like underscore UDP, TCP. So we don't want to do the CRUD. So I didn't try to do just encapsulation of existing DNS message formats into graphs, but try to basically map it in the most efficient way so that in a graph solution alone, we have as little unnecessary overhead as possible. So what do we do? And I just wanted to quickly give some very high-level overview. So there is more detail, obviously, in the draft. The draft, of course, is by far not complete. It's a 0-0, right? So first of all, we want to be able to simply reuse and grasp service names from that have been assigned by 6335. We want to have the same ability for service criteria, priority weight. Service instance names is an interesting thing. The service instance names, in my interpretation, please correct me if that's wrong, is primarily for manual browsing so that a human can make nice decisions. Otherwise, you start rather in automatic selection, rely on the key value pairs also to compare parameters of service to select the best one. And Stuart?
Couple of quick comments. First, I want to say very clearly that I agree with the first point you made. And I'm saying that, well, first point verbally, not on the slide. There is absolutely no reason to be encapsulating the DNS packet format. And I'm coming up to the microphone to say this because this is a common misunderstanding. To my mind, the key concepts, and maybe we chose a bad name. Picking a good name for something is always very important, and maybe we didn't in this case. The most important concepts in DNS service discovery are the three basic operations. You offer a service on the network, you discover a list of available services of the type that meets your needs, and then when you've picked one or more to use, you may need additional information to actually establish a connection to that service, a TCP connection, a byte stream, a message stream. But so the three operations are offer, discover, and use. And the current implementations of that encode those semantics in DNS records and DNS queries or multicast DNS, but there is in no way that we are wedded to that particular packet format. I think we would support the concepts as being the useful concepts, but how you encode those absolutely should be done appropriately for the link layer of the environment you have. So 100% agreement on that.
Yeah.
Do you want to answer that?
No. Thank you very much. I mean, that was kind of the intention here. I think it becomes more interesting when I'm starting to kind of declare certain things for the use cases within Grasp Anima to be potential CRUD that, you know, I'm not sure if I want them at all. Right now, I've defined a couple of things as optional, and so basically that would be great work to come to conclusions on, right? So, for example, the service instance names, right? So it's a great thing if I'm in front of a web GUI and can select as a human. If I have a bunch of automated ASAs that are trying to select a service instance, I think I'd rather have a more explicit algorithm that goes to key value pairs and compares parameters, and there's some known, you know, prioritization scheme, right? So that would be an example, which is why for here now the service instance names are actually optional.
So on that subject, I think I partly agree with you. I think having service instance names as a way of differentiating things on the network should not be optional, because you need a way to identify the things that you're talking about. When you want to make a connection to something, you have to say what it is you want to make a connection to. So having some identifiers, I don't think is optional. Whether those identifiers have to be crafted for human consumption is a separate question. And I can give you one example showing that I think we're thinking along the same lines here. One of the things that we support in the Apple product line is a sleep proxy. So you can have, and this is maybe less relevant now that pretty much all printers have Wi-Fi built in, but if you put your mind back 10 years to when most inkjet printers connected over USB, it was common for people to run printer sharing on their desktop iMac. And in fact, it's still there in system preferences. You can see the printer sharing checkbox. But if you leave your iMac powered on 24 hours a day just so you might want to print something, then that's not very good for the environment or electricity bill. So what will actually happen is your iMac will go to sleep, but still be available on the network, so that when you pull out your iPhone and you print your boarding pass, the thing wakes up, prints the document, goes back to sleep again. And it does that by transferring its service state to a proxy on the network that can answer on its behalf. And it does, and sort of like many protocols, there's a recursive self-dependency here. If you want to find something on the network, we have a service discovery protocol. and it uses multicast DNS. The service type is sleep proxy, but those instance names are designed for machine consumption, and there are a series of numbers that encode the power on consumption, the idle power consumption, some notion of the mobility of the device, going from like an iPhone being the most mobile to your home NAT gateway being the least likely thing for you to walk away with, and you'll probably have noticed or not have noticed that there is no UI on the Mac for you to choose the sleep proxy. It just goes to sleep and it picks one based on its own algorithm.
Yeah.
If you look in system preference, if you look in system information, you will see it list the top 3 sleep proxies it's found on the network. Anything that's powered on all the time, your home access point, an Apple TV takes 3 watts and is typically not a mobile device. So out of all the possible proxies on the network, it picks its first 3 choices and shows those, and you can see the metrics it's using.
And it also just another point that comes to mind listening to is this is basically the question about when do you need locators versus identifiers for instances, right? And so right now, I think I came, for example, from all the protocols where the locators are sufficient to distinguish identities, right? But of course, if you have a protocol where the locators are not sufficient, but you also need the identifier, so typical thing would be HTTP, right, where the server name is not implied by the ports, then of course you need the identifier then right now. That would be another reason when identifiers are really necessary for a service.
I think if you're not using service instance names, the answer is you must have some other hidden identifier.
Yeah.
If you've got 3 things on the network, you have to have some way of telling what they are.
But obviously, we're trying not to have, trying to have as little as possible to make it as simple as possible. So in that case, I think the service instance identifier would be that identifier.
Okay, then I think we agree, because we also want to keep it as simple as possible, and there is only one identifier. It's called the instance name. You could give it a different name if you want, but there is only one, and it's consistent across all services.
So, and then the last one, of course, the host name, right? Just, I think, I'm not quite, is it kind of being an outcome of DNS, the way it works, right? That you're kind of not directly getting over to the A records, but first to the host name records and then the A records, right? So that in the kind of in Grass, we don't even have host names normally, right? So that's something that would also be, I don't even think I have in the definition the option to have host names in service announcements.
That is, there's 2 answers to that question. Partly it is, as you say, an artifact of the DNS SRV record format,
Right.
where it doesn't contain.
Oh, right, you inherited that. That wasn't
Right.
original.
It doesn't contain an address, it contains a host name. The reason we chose to inherit that and not invent something new, I think, is the same reason that the SRV record was defined that way, that not all the time, but in many cases, that extra level of indirection is valuable, because a given target device might have multiple IPv4 addresses and multiple IPv6 addresses and multiple active interfaces. So saying this service is reachable at this port on this host, and by the way, there are 8 ways of reaching that host, and maybe your happy eyeballs racing algorithm will try all of them in different orders. The alternative, if we defined a new variant of the SRV record that went straight to the address, you'd end up with 8 SRV records for the service. So it was definitely an interesting design choice, because there were benefits on both sides.
Yeah. And in our case, if we figure out that we want to have that indirection, I mean, what we have as locators right now cannot only cover addresses, but it could also cover host names, right? So I just haven't found a good Anima scoped example use case of that, but once I have one, I would kind of introduce that option.
In the machine-to-machine use cases for MDNS, quite often the solution is that
MAC address is the name.
some
something
gobbledygook GUID type identifier, like the new garden irrigation controller I got. The host name it has is Android dash, and then the 12 hexadecimal characters of its MAC address. Now, a normal human user never even sees that. They just on their app, they just tap it and it opens and the host name is. So that is an approach people take, as they
Mhm.
put in effectively a dummy placeholder for that.
Yeah, but I mean, given how we haven't really explored the whole space, but are always scared of these, yesterday type 1 devices, less kilobytes, right? And so one of the ideas was, of course, also to keep the coding and encoding of the information as compact as we can and eliminate all the stuff we don't need. So this is basically, if you haven't seen CDDL, the CBOR presentation thing, that's basically how it's specified. And I just summarized it a little bit. So basically we have a naming scheme for our objective names. If it's served dot, a 6335 service name, then basically that's what it's meant to indicate. And we don't have to specifically register it again in our own objective name registry. And for host name resolution, which I haven't talked about, I would do name dot something, some host name, if you want to do that. And then the service element, all the data is basically in this structure. So kind of if you want extension, message type, now you gave me some other names. So I came up with describe request, enumerate request. That was a little bit driven from your RFC. But I think we're just using somewhat different words for what you would like to see as the abstracted API name. So that would be great to talk about. Service name, service instance name, domain kind of now with the way Grasp is mostly empty because it's mostly like .local, only that it's the global network of 50,000 routers, so kind of .global, if you like, but really not very structured. Priority weight, KV pairs. The range is a thing, so because in Grasp we're kind of doing flooding hop by hop with time to live decrementation, we can know the distance in the service of a service instance. So I came basically up with parameter range that allows to define nicely how to prioritize distance-based service selection over priority weight. C locator is then exactly the locator. So, and that also is not only kind of, addresses or names, but a context, which is a string, because we have different DRFs that we need to work with, right? So one would be the default, like where the announcement is in the ANI ACP or other DRFs in the network infrastructure. And then, I'm not going into exactly how we're mapping these for service types onto the different Grasp message types that we have, the flood of an announcement, the flood of a request, the unicast responses or so, that's in the draft. There's also from Monday in the slides in the Anima working group more detail on that. So what's the target system overall that I'm imagining, right? So overall, kind of for the specifications of anything we're doing in Anima in the future, simpler, more consistent specification of ANI ACP services, kind of one line, right, that says, the service documented here is the following name in the INI registry, right? Parameters are according to Dnssd done, right? Dnssd graph, right? Because as you saw, we have some additional parameters. Common service name, announced discover API and SDKs, which might be a superset, so that, depending on context, it would automatically use Dnssd, unicast, MDNS, or Grasp. That would, for example, be great for the Brewski stuff, where we actually want to specifically also highlight how to do non-ANI solutions where actual MDNS would be used, or, DNSSD. We'll have to check. We haven't invested that much time there. Gateway functions in the NOC router, right? So, I mean, Abahi and others are easily able to quickly put all your NOC equipment in a state that it announces itself by MDNS, and then the router does the gateway between MDNS and Grasp. That's also what the Cisco product does, only that it does multi-hop MDNS in the network, and that kind of didn't really work. So I'm very happy that we came with Grasp and the flooding mechanism we have to a better solution there. So what is outside the Anima scope, and that's now where the discussion with Terry was very useful. So one set of limitation and the current definition I think makes a lot of sense is really scoping ourselves to the Anima use case in terms of everything we need for operational things, because you can always bring up thousands of more things that are great, but that would apply to user services use cases. And so then the question is, how do we capture that? And that's certainly something we wouldn't want to do with a draft in Anima. I'd be very happy if somebody wants to pick this up and say, hey, this type of flooding graph might be useful to also as an alternative in some scenarios for let's say the hybrid proxy thing, right? So in comparison, the hybrid proxy is better if you have a sparse receiver population because you don't need to flood everywhere. But the flooding, of course, is a very efficient scheme if you know that every device in the network needs to know the information, right? So but again, outside NMA still. And I think that was it.
Thanks for coming and doing this presentation. And thanks, David, for thinking of setting this up, because I was not aware of the details of this work. I'm very happy that you decided to adopt the same service namespace run by IANA, because if nothing else, that provides a consistent way of naming services, regardless of what the bits on the wire or over the air look like. The concepts are compatible, and that's really important. So thank you for doing that instead of inventing yet another service namespace.
Exactly that. And by the way, I mean, so I'm trying to hire, Brian as a co-author for all the graph stuff. I bet I also would be very happy if anybody interested in DNSSD would be, be interested to co-author that, just to basically bring in all the DNSSD expertise.
And I think the prospects of a gateway functionality, because if the concepts are compatible, that makes it possible to gateway between different implementations. I don't know whether the timing would work out, but that would be a cool thing for us to sit down and try out at Hackathon in London.
So Brian Carpenter again. Just to be clear, we have a namespace for grasp objectives, and what this does is provide a very neat way we can extend that namespace to automatically include the entire DNSSD namespace, which I think is a nice property, but we need our own namespace for the objectives that are very specific to autonomic functions and not really what you could call a service as such, right? Because a lot of our objectives will be network parameters rather than services. The other thing I wanted to say, as you probably realize, I played around a bit with interfacing grasp to DNSSD already. What I haven't tackled is parsing the DNSSD results into the kind of representation that Turles is describing. And once I understand the format that I'm trying to parse, I think that's a relatively straightforward thing to do, at least in my choice of implementation language, which is Python, which makes this stuff very easy. It'll be much harder for someone who decides to do it in C.
Thank you, Charles. Has anyone seen the blue sheets? Has anyone not signed the blue sheets? So now our next and last topic for today is going to be on Dnssd privacy. We had documents adopted by the working group on this topic, and Stuart now has a new document looking less into the proposed solution and more into the requirements. So this is meant to be a very interactive conversation on what we're trying to accomplish as a working group in the domain of Dnssd privacy. Go ahead, Stuart.
Thank you, David. So we have some drafts by Christian Wiedemer and Daniel Kaiser, neither of whom are able to be here physically for this meeting. And they cover some interesting areas. Earlier when I was speaking about the last call results on the Discovery hybrid, I had a couple of asterisks saying there are questions about privacy and information leakage. And it's a sign that I think there's a lot more awareness of that right now. 10, 15 years ago, if you go back to Apple Talk in 1987, the fact that you could discover things at all without typing in addresses is pretty miraculous. But now we all have wireless mobile phones, and the prospect of having information tracked about us is much more worrying. So after reading Christian and Daniel's documents, I was trying to make sense of what I thought of them, whether I thought the proposals worked well, whether there were things they didn't do, and maybe they didn't do them because they didn't think that particular thing was important. But it was not clear to me what their goals were for me to judge whether they achieved those goals. I'm aware of a bunch of activity that is going on now and recently in this area. They're the drafts by Christian and Daniel. For those of you who have used AirDrop on your iPhones, it's something that that team thinks about a lot. You can set AirDrop to only receive files and contacts and photographs from people in your contacts list. So if you set it in contacts only mode, you're only discoverable by people that you have in your contacts list. But we want to do that in a way where you're not walking around broadcasting, these are all the people I have in my contacts list. And when you're trying to initiate a file transfer, we don't want to be broadcasting, this is my identity. Does anybody out there have me in the contact list? Because that way you could, if you gave your name, your email address, your phone number, you'll be broadcasting that to any eavesdroppers around and trusting the ones that aren't supposed to receive it to throw it away. We could do a hash of your email address, and a one-way hash would make it seemingly harder to reverse engineer what the email address is. But if the email addresses are something at iCloud.com, it's pretty easy to do a dictionary attack against common names and figure out a match. So even a hash reveals your email address. The other issue with a hash is if it doesn't change, even if it's not reversible, if it's the same every day, you've now created a tracking identifier. We may not know who you are, but we may know that you come into this particular cafe for a cup of coffee every morning. Things like this we didn't care about 10 years ago, but we definitely do now. So AirDrop does some in that area. It's probably not perfect, but it's certainly one of the goals they had in mind in the design. Same thing goes for the HomeKit home automation accessories. When my phone is looking for my accessories it can control, it has got to transmit some kind of query that in effect says, I'm looking for Stuart's home accessories. I'm looking for the thermostat and the door lock. But it has to do that in a way that when I'm here in Singapore, my phone is not broadcasting my name and my address and my account details. So again, we need a selective service discovery that does not leak private information. Google has their Nest product line with the thermostats and the smoke detectors and the cameras and the whole Works with Nest partnership. They have similar concerns. They don't want devices broadcasting your identity. The Zigbee community that traditionally has done home automation for the last decade or more using their proprietary protocols over the 802.15.4 radios, they are now moving to running over IP using the Thread mesh network pioneered by Google and others. They have similar privacy concerns. There are other projects I'm aware of that's confidential, and there's another project that I'd actually forgotten about from 5 years ago, and the only thing that reminded me about it is I got one of those little brass patent plaques in the mail at my office saying, congratulations, you have a patent. And I went, wait, really? I totally forgot that I'd helped that team with that and they'd added my name on the patent. So that reminded me of that long dead project. And I've asked Apple Legal to make that IPR disclosure. It may or may not be relevant to this work, but we should disclose it so that other people can make that determination. And these are just the ones I know about. There's probably many more. So I realized for us to really evaluate all these different things that are going on and figure out if any of them have in fact overlooked something important, it would be good to take a step back from any specific solution and figure out what are the things that we are concerned about here, and debate. Are they important? Are they not important? So to that end, I wrote a quick document outlining at least a starting point of the things, some things to consider. And the purpose of this discussion is to talk about which of those are right, which are wrong, which additional things we maybe should add. So one question, and I'm wording this in a way that's not specific to the DNS message format, but I hope is generic about any kind of discovery, and that ought to include grasp and things like that as well. The three basic primitives, to my mind, are you have something offering a service on the network. In today's terminology, that means it has a listening socket, it's accepting incoming TCP connections or incoming UDP packets, and it's running some kind of application protocol. And to communicate with it, you have to know the application protocol to send it meaningful messages that it will understand. For a web server, you might send HTTP GET. For a mail server, if you send it an HTTP GET, it's not going to do anything useful. So that whole package of what do I offer, what's my address, what name or other distinguishing information describes it, all of that is what I'm calling offering a service. You may have something like the terminal room printer here, which is offering a public service. It is there so that we can print documents that we need to print. So it doesn't make sense for that to be secret. There are other things that may be secret. If I have an implanted blood sugar monitor or an insulin pump, then it is offering a service that my iPhone health app can communicate with to check my blood sugar level. But it doesn't mean I want to be walking around broadcasting the fact that I have an embedded blood sugar monitor to everybody within range. So that's an example of a service that you want to offer, but only offer to authorized receivers. Discovering is the client-side operation, which is here at the IETF, you tap the AirPrint button on your iPhone, it will show you the terminal room printer is available. Right now we only have one, but if there were 2 or 5 or 10, you would see the list to choose from. So that is the step of discovering services. And again, the entity doing the discovering might want to keep that confidential. If my iPhone is looking for blood sugar monitors, then whether or not I have one or whether I have it with me, I may not want the iPhone broadcasting to everybody within range, hey, I'm looking for blood sugar monitors because I have a diabetes app on this phone. And then the final step is having discovered a list of candidate services. In many cases, you're going to pick one to use it. And that use operation might also want to be protected and confidential. Many times I may skip the discover step. So to use the example of the HomeKit accessories, when I'm setting up a new accessory, I may want to do a discovery for all home automation accessories I can communicate with. Once I've paired appropriate accessories with my phone may be just looking for the door lock. And it is saying, when I come within range of the door lock, unlock it. So now it's not browsing for all door locks. It's looking specifically for my door lock because that's the one it has the credentials to open. So again, we don't want it constantly broadcasting, I'm looking for Stuart's door lock, Stuart's door lock, Stuart's door lock. We want a way that it can indicate what it's looking for in a way that the door lock itself will recognize, but to everybody else is undecipherable, encrypted nonsense, and nonsense that changes because it can't be a constant ID that becomes a tracking identifier. So those are the three primitive operations: offer, discover, and use. When we're talking about who we trust and who's trusted and who's untrusted, there is a question of granularity. Are we talking about doing this on a per device level? Like once I authorize my iPhone, all apps on the iPhone are equally trusted. On a multi-user device like a laptop that might have multiple user accounts, are we doing this trust at a per device level or a per human user level? I'm not taking any strong position on which of those is right or wrong. I'm just pointing out that any solution we discuss ought to state clearly what its model is, and that helps us understand whether it's suitable for the use case that we care about. So once we've talked about the operations and the granularity, the question is, what are the threats that we're worried about? What properties do we want? And here's a list of 7 that I thought of, and the point of this is to solicit other thoughts on this. We start with the obvious ones. We want to know that the data is real and hasn't been modified. We want it to be confidential so that eavesdroppers can't see in the clear what we're doing. We want anonymity so that the act of doing a question or the act of offering a service is not revealing information about ourselves. We also want all of those 3 things done in a way that's resistant to dictionary attacks. We want it to not be a constant unchanging identifier at any level. That includes MAC addresses, IP addresses, service identifiers. There's a subtle question of message linking, because there are attacks where any individual message doesn't reveal any critical information, but you can associate different messages with each other in a way that does reveal sensitive information. So that is a factor to be considered. And then finally, denial of service is a threat. If we're not careful here and we build protocols that require heavyweight crypto operations on every received packet just to discard it, then that risks making it a trivial attack to drain the battery on your phone just by sending it garbage that has to decrypt. And then finally, there are some other miscellaneous considerations we shouldn't forget. One is things like the sleep proxy stuff I was talking about earlier, where when your device goes to sleep, it hands its state to some other device on the network that can answer on its behalf while it's asleep. If we require crypto operations done for every operation, requiring secret key material, we may not want to hand our secret key material to an untrusted proxy on the network. So figuring out how the privacy and the power management fit together is a challenge. It's easy to make protocols that don't scale very well. One way to do this is to discover everything in the room and do pairwise Diffie-Hellman exchanges with each one and say, do you have the secret key? Do you have the secret key? On paper, that has the right properties, but in terms of battery consumption and spectrum consumption, that probably is a non-starter. And then finally, everything I've said so far presupposes this idea of knowing who we trust and who we don't trust. And then the question is, how do you establish that trust in the first place? We're all familiar with the traditional kind of garage door opener model where you press the learn button on your garage door and then for the next 30 seconds, any remote that transmits a code gets trusted. In the 1970s with garage doors, that was probably fine. In today's world, with things like the Mirai botnet attack, we have to assume that we may be surrounded by malicious attackers at all times. And even a 30-second vulnerability is probably not acceptable. If you get a brand new printer out of the box and set it up and put it onto your network, the moment you press that learn button, some man in the middle running on some compromised bit of equipment could intercept that. So we want ways of establishing that trust relationship that don't have a leap of faith. Trust on first use has worked very well. Famously, SSH does that. The first time you SSH to a host, it will tell you, don't know who this is. Do you want me to store the public key? And you say yes. You cross your fingers that that's the right host. And if it was, it protects all future accesses. But if you're intercepted the first time, you may have just got a man-in-the-middle public key stored in your SSH known hosts. So a way of doing that setup that is not vulnerable would also be desirable. The good news is we now know how to do this. The HomeKit specification uses something derived from SRP, which is the Stanford Secure Remote Password. It's a way of doing a zero-knowledge proof of knowledge. There are other encrypted key exchange protocols like EKE, Speak. There is recently an RFC for JPake. Pake is P-A-K-E, Password Authenticated Key Exchange. And I'm very happy that these things are now well understood, because we should be using those for all future pairing protocols and device provisioning protocols. We should be using these secure key exchange mechanisms. So that is the overview of what I've been thinking about with privacy. I want to thank Christian and Daniel for their work over the last year or two on writing the drafts on that. Unfortunately, they're not here in the room to participate in this discussion, but now it's everybody else's turn if they have things to add to this.
Thank you, Stuart.
It's Dave Ruffin. I have one thing that I heard just now that I hadn't considered before. I've been following this work and followed everything along until you said the pattern, the signature analysis gives away who you are. Even though the exchange is completely encrypted, completely undecipherable, I can still tell by the number of packets and the size of the packets that it's a blood gas monitor that you've just bound to. So are we now adding in what some other protocols I've been involved with have, which is jitter, padding, random messages that contain 100% padding, just to completely jam any kind of pattern recognition? Is that now on the table as part of what we're doing?
Yes, thanks for that suggestion. I didn't have something to make notes here, so can we just make sure that's recorded in the notes? I'm certainly not saying that in all cases padding and jitter and randomness and dummy traffic are necessary, but we should definitely include that in our toolkit. For the things that are especially sensitive, we should be thinking about that as well.
Right, yes.
Michael Abrams. So you mentioned a lot of examples of things already in this area. I just took a really quick through the draft. I didn't see like a list of examples and so on that you just gave. Is it in there and already, or could you post that to the list or something? You have a lot in your brain, I'm sure, when it comes to examples. So that would be useful.
That list of examples is not in the draft right now, but I can certainly add that if you think that would be helpful.
Yes, that would be very helpful. Thanks.
So, in general, I kind of like to poll the room to see how people feel about working on privacy. Quickly, could we have a quick show of hands for if you think that this privacy work is useful and if it should be done in this working group?
So David, actually, to clarify that, there's kind of two questions that you're asking there. One is the draft I just submitted, which is a framework for thinking about things. It doesn't propose any solution. And then the second question is whether we should continue with things like Christian's work about actually trying to solve these problems. So maybe we should ask those two separately.
Yeah, sorry, or rather, I would say a more general question of should we be looking at privacy in the first place? I think from the interest there are also at the answer is yes. I just wanted to let people an opportunity if people think it's a bad idea altogether.
So we've already adopted Christian's documents.
That is,
yeah. Point one. Point two, you should probably ask for a hum, not a show of hands.
All right, apologies. So going back then to Stuart's document, which discusses the use cases and what we got, I'm going to ask for a hum if people think that we should be working on this, if we should adopt this as a working group document. Of course, we'll take that to the list. So I'll ask first for a hum if you think we should adopt this, and for a hum if you think we shouldn't yet.
Privacy draft that was already been adopted.
Yeah, it's Stuart's draft.
No, well, it's got like 4, right? So the privacy one's already been adopted. pairing one, the feedback as well.
Yeah, but
Privacy, yes, okay.
And just to give a bit more background, Kristen and Daniel have been working diligently on their privacy and pairing documents without, to be honest, a lot of other input from working group members. And partly that's my fault because I was busy with some of the other areas that we're working on. When I had time to focus on this and realized there was a bunch of interesting, important stuff there, we had a conference call with Daniel and Christian before this meeting because I realized they wouldn't be here. And what Christian and Daniel said was their documents have sort of formally speaking been through the process of working group scrutiny and last call, but they haven't really had widespread adoption. Daniel and Christian have an implementation, but nobody else does. And neither of them want to push through an RFC for the sake of having an RFC if it's actually not going to be used. So both of them would be happy with kind of putting those documents on hold while we get more scrutiny and more discussion. So this is not something that we're springing on them unannounced when they're not here to hear about it. We've already discussed it, and that they would rather see us do good work than rush ahead publishing something that hasn't had a lot of overview.
Ted Lemon, I thought actually we did give it a fair amount of review. That's not to say that doing a little bit more work on the motivating use case is a bad idea, but we did do a fair amount of work on looking at the document and talking about some of the issues that you've raised in this slide deck already. Again, not to say that we shouldn't do this, but I actually am pretty enthusiastic about the work that they've done. So.
Anshul Malhotra from Boston University. I just have a question. The Stewart's draft just states the goals of privacy and the drafts of the drafts that exist already. Do they meet all these goals or do they not? Or like
The current drafts from Daniel and Christian, in my opinion, do not meet the goals. If I'd read them and thought, yes, this does everything we need, then we probably wouldn't be having this discussion and I wouldn't have taken the time to write that requirements draft. It's because I think there are gaps in those documents, but what I wasn't clear about was whether those gaps are errors, are they mistakes, or are they things that they were not trying to do because they didn't think it was necessary to do those things. And that was where, when I was in the process of trying to write feedback to Daniel and Christian, and I found myself not being sure how to write the feedback, because on the one hand I could say your proposal fails to do the following, but if they didn't think the following was important, then their answer would be, yeah, we that's what we meant. And that was when I started to realize that we actually didn't have a clear understanding of what we thought was important and what wasn't. At least in my mind, that's what I thought, and that's what we're here to discuss. If everybody else is clear on it, then maybe it's just me who's confused.
the goal of this draft is to stimulate discussion that whether we want more privacy, whether we want to meet all of these
Yes.
different goals. Okay. Right. Anshul Malhotra from Boston University.
I think Barbara would like to see your badge so she spells it correctly in the minutes.
Anchal, Anchal.
Safer. So I think there's a little bit of overlap in intent between this draft and section 2 of the working group documents. I'm actually commenting on the way that they're phrasing the question. And I think Stewart's draft actually covers in more detail or elaboration on a generic sense. And section 2 of the Dnssd privacy document actually covers sort of specifically privacy issues in the Dnssd protocol as it exists or is deployed right now. And so the question that you were starting to ask was, does the working group think that this is interesting? Well, if they didn't think it was interesting, they probably should be arguing that Section 2 should be removed from that document. I think because it actually is a working group item right now. I think the question is really, should the privacy considerations or requirements or whatever you want to phrase it be split into its own document, which is actually what I believe the approach that Stuart is taking is actually better phrased that way. And whether Section 2 is then, if the answer was yes, then whether Section 2 is moved into that document or kept in here and normatively referenced, it would be a sort of subsequent how you might implement that. But I think the evidence of Section 2 being present and Stuart saying, well, I got a lot more to say than what's in Section 2 right now, is that the fact that this is a working group item right now means that I think that the working group has said that having some analysis of what the issues are is already roughly a consensus, because I haven't heard anybody arguing to remove that from that document so far. So I'm just commenting on the way that you're asking the question. So
Yeah, just to follow up, Christian's document is mostly about resource record type stuff. That seems to be, especially around Section 2, Dave, I believe.
well, there's privacy implications of Dnssd.
Yep.
There's privacy implications of publishing service instance name, which starts getting sort of Stuart's taxonomy, and that's the publishing section and so on. So I see it as a very specific instantiation, and Stuart's document is about the general principles and considerations.
Exactly.
Yeah. So I think they are somewhat complementary, but I'm just saying that because there's already a working group item that does touch on these here, I'm coming on how you might phrase the question. Do people think that this is interesting? You might have to say what this is. So should a more generic exposition on the security principles, the privacy principles and considerations be put into its own document would be a good way to phrase the question, in my opinion. And is Stuart's document a good starting point for such a document?
It's a good way of putting it. Thanks, Dave.
I'll talk TOKER. So this kind of work is very important. We've been looking at some of these leaks, private information, as part of the human rights considerations in terms of surveillance. So I think it's very commendable to keep pushing forward with this. And if there are some areas of review that you need, we can also pass that over with the HRPC group to support that. I just wanted to mention that. Thanks.
Yes, thanks for bringing up that angle to it. I was talking about medical information and privacy, which may be important in various employment contexts. I think your human rights issues are maybe a much more extreme example of that, where in some cases people's lives are in danger if they reveal information that they shouldn't.
We're just trying to formalize the right question. So basically, I think we want to do a whether it needs to continue, and then we'll figure out how to sort of merge all this stuff together. Probably the best way to put it.
So, thanks to everyone for the input, and we want to ask the question of whether what was in Section 2 of the previous draft, so the requirements, should be expanded on. So it could be in Stuart's document, or it could be in something else. But the main question is, do we think it's valuable for the working group to be spending more time on expanding the requirements? So I'm going to ask for a hum for working on these requirements and a hum against. If you think we should be spending time on this, please hum now. Thank you. If you think we shouldn't be, please hum now. So let the minutes reflect that sounds like the should was what people think we should be working on this.
And how it all gets fleshed out, whether it's a separate document or something like that, we'll leave that all to the list and sort of let that all hash out that way. I think it's a better way to do it. Oh, unless Mr. Sullivan's got something eloquent to say.
I'm Andrew Sullivan. So I don't like to chair from the floor, but I noticed that the people who thought we should work on this didn't seem to be very loud. And so I guess the other question is, how many people who think we should work on this are actually going to work on it? Because that's the other question.
yeah, I think the question I was going to ask after this was, can we get any kind of show of hands to see people willing to review this or sort of work on the draft in this room? Please raise your hand. I see Ted. I see Andrew. Is that Took? Okay. So, Miss Barber, if you can write those names down so we can hold them accountable, that would be great.
Put your
It
hands
was
up again
Ted.
so Barbara can see you.
Yep. Yep. Yeah. Yes. I think that's about it. Yeah. So, do you have anything else on your side, Stuart? Okay.
All right. Thanks to everyone who offered to review the document. Where's the last blue sheet? Please do. So a quick wrap up.
So I'll speak up here about the session signaling draft. As the DNSOP co-chair, I'd say about half the room attends DNSOP and the other half doesn't get their hands dirty. So those folks actually, it would be useful from that point of view, like Rolis and Brian and stuff, if you can sort of read the session signaling draft as we're getting ready for working group last call and sort of take feedback on that. So I think on our side, we would appreciate that. Thanks.
So quick wrap up. Today we reviewed the status of our documents, which are moving along nicely. Thanks, Tim, for the support from DNSOP. We had a brief report on the hackathon, which sounds promising for future work. We dove into the interaction with HomeNet, which was great. Yes, Stuart?
You just reminded me, talking about the hackathon, we would like to do that again in London. So, and hopefully with some more people this time. So I'm hopeful that we'll have more code written and more interop testing that we can do next time.
Thanks. If anyone's interested in this, please reach out and email Stuart so we can get a more team. That would be great. We also explored how we can collaborate with Anima on service discovery. So, I mean, I love if we can continue these conversations and maybe even have running code at the hackathon. That'd be amazing. And finally, we went into the service discovery privacy, where it sounds like we have a consensus on working on this and detailing more what we need to do, and a good mass of people who actually want to review the document. So I think this will help us move forward. That's all we had for today. Thanks to everyone for attending, and see you all in London.
No, if you know where the other blue sheet is, just sort of raise it up and I'll go get it. and